Welcome and thank you everyone for joining. Today we'll be talking about decentralized logic execution, and we have our technical team with us who will give us more insights on this topic. As always, you can send your questions to the Q&A box or like on the chat window, or also by raising your hand, and we can unmute you. And yeah, taking over to you, Toby.
Great, yes. Thanks for joining everyone on this webinar on decentralized logic execution. To guide you through today on this topic will be myself. I'm a solution owner here at EnergyWeb.
Yes, and I'm John. I'm a senior solution architect working on EnergyWeb's identity team. Over to you, Camo.
Yeah, and hey guys, my name is Cameron and I'm DevOps lead, leading a DevOps team here at EnergyWeb.
And yes, so we would like to say that we found a really killer use case for Web3 in our ecosystem already. This is the decentralized approach to identity and access management. We often refer to this as our switchboard product. And today we're really happy to report that we have found another one, and we're calling it decentralized logic execution. So what are the objectives of today is to really understand the problems that decentralized logic execution, or DLE chains can solve, understand the basics of DLE and proof of good work, know where DLE can really make a huge impact in the energy sector. And then I'll hand over to John, who will explain the importance of secured decentralized identity resolution and credential verification. Camille will explain how all of this can be packaged together and utilized by enterprises. And then we'll finish on questions and answers. If you have any questions throughout the presentation, please feel free just to write them in the chat and we will come to them at the end. And also during the Q&A session, you can, I think there's a feature to put your hand up. You can also put your hand up and we'll try to get to as many of you as we can to answer those questions. So this is the problem statement. So on the left, we have the current market landscape, or at least for certain markets. And I've synthesized this into a problem definition. So with the local energy markets, they are local by design. Local parties want active participation and to be decision makers within the network. And often there are quite stringent geographical requirements, such as the nodes must be operated within the confines of a certain geographical region, and the data cannot flow outside. We have multiple distinct stakeholders with distinct roles and objectives, such as the transmission system operators, distribution system operators, market operators, regulators, aggregators, etc. And then there's also varying layers of privacy and verifiability on certain data. So for example, raw input data to a business process is often highly sensitive and cannot be public. But the business process outputs need to be shared with local participants. Certain participants need to really verify that the business process outputs by other participants are accurate, as this can greatly impact their own operation. And some business process outputs, or part of the data set of the output, also need to be publicly verifiable. An example of this is auditors, regulators, shareholders wanting to verify a claim of 100% 24/7 carbon-free energy consumption over a year. And then we have a need for a high degree of customization within the networks. So local markets or specific business applications, they want to run a network that is configured to specific business needs. So they often want to configure and tailor things like the governance mechanism, the onboarding and administration process of validators, the block time of the network, for example. And all of this can't really be configured in an existing public network with predefined network specifications. So if we look at the problem definition now, this has really been synthesized into this problem statement. So to meet the challenges of the landscape, there really needs to be an enterprise solution out there that can offer customization, ability to ensure nodes and data flows can remain within confines of geographical boundaries, private and permission access for participants, and the ability for participants to verify the results of the business logic executions of other nodes in the network. All of this while also being able to benefit from transparency, finality, and security of a public blockchain network. So here we are looking at the current solutions on the market that are trying to solve these problems. And if you compare these current solutions to the problems I've defined earlier, so if you look at the private decentralized ledger, it is highly customizable network with permissioned participation, but there's a clear lack of interoperability and communication with other external chains. Not all participants can verify the outcome of a node's business logic. There's no ability for any of the business process outcome data to be verified publicly. There's also no cross-ledger consensus or communication. An example of the importance of this is the double spending problem. So for example, if you have a service provider offering a volume of flexibility in one local grid flex market, that same provider also participates in a national wholesale exchange on a separate network. You need to ensure that the same flex volume isn't counted twice and rewarded twice. So in order to achieve this, you really need a shared state across ledgers. And if you look at a public decentralized ledger, it's publicly verifiable transactions, but there's no degree of customization at all for your particular business process needs or local energy market needs. There's no localized verification of business logic between the different nodes participating in the network. There's obviously a huge complexity when processing sensitive raw input data, and also with ensuring which parts of the output of that process also remain public, which can be verified. And also smart contracts really aren't designed for such sophisticated and complex business process execution. And that point also applies to the current state of private decentralized ledgers as well. So that brings us to decentralized logic execution. What really is decentralized logic execution? Well, we found a way to embed energy market and business critical processes or work into a blockchain. So each participating node in the network executes the same business logic. They submit their result to a consensus mechanism palette. The consensus from all the nodes' results becomes the final result output of the network. And rewards are issued for correct results, derived as quickly as possible. So you can imagine a network of multiple organizations running nodes with embedded business logic and really competing to produce fast, accurate results in the most efficient way possible. You can compare this somewhat to the proof of work mechanism using Bitcoin network. You have nodes competing to solve a very complex cryptographic problem as quickly as possible, but the work itself is actually useless in the Bitcoin network. It doesn't serve any purpose. What we are doing here is the work itself is a useful business critical output. So the computation efforts within decentralized logic execution, or DLE chains, is actually executing business critical logic and then creating a consensus around the result of that. And this is what we call proof of good work, as opposed to proof of work. And here you can see this little circular diagram. You can see that the more assets connected to such a network, the more data processed, obviously the more computationally intensive the mechanism or the logic execution becomes. However, the greater the reward for the winners, as greater service volume means more payments. Therefore, there's more incentive for participation, and you end up with more participants, greater security and reliability in the DLE chain's results and outputs. And so, yeah, here is a slide to sort of illustrate this point. This is the proof of good work mechanism, quite a high level diagram here, but you can see we have input raw data. This is, in this example, it's generation data. You have the worker nodes who have the embedded business logic, and they are executing that logic. They're processing the data. Each node then submits the result of their business logic process, and an on-chain consensus mechanism palette reads all of the results and determines the consensus, and then provides the result of the consensus to the data consumer. This result of the consensus becomes the output of the business logic execution process. So here we've come up with a sort of decision tree, just to sort of show that, you know, DLE isn't the answer to all problems, but if you can answer yes to these questions, or if you can follow this tree, you'll find that it's very necessary for many processes and many solutions. So if we just start with, do the results of the business process need to be verified by another party or other parties? This can be publicly verified or verified locally by other network participants. If no, then a centralized logic execution should probably be sufficient. And in fact, probably blockchain solution isn't actually necessary for that use case. If yes, then we can move on to the next one. Can the data that's input to the business process be public? If no, we would recommend a decentralized logic execution, customized to certain requirements of the solution. If yes, then we have another question here, which is, does the business process have stringent performance requirements? If no, then a smart contract deployed on a public blockchain would probably be sufficient for this solution. But if there is a high degree of complexity required in the business logic execution, we would really recommend a DLE chain here. So these are just some examples which we are working on already with some of our partners in this space. So, we have the operating envelope partitioning. The operating envelopes are time intervaled operational boundaries within which devices can ramp up or ramp down their input or output. So this is like a flexibility boundary. And if the boundary is to keep the devices within the physical and operational limits of the grid infrastructure. These operating envelopes are sent in a raw batch data form, and they need to be partitioned, processed, and mapped to the aggregators who are responsible for running each of these national metering identifiers. So these are the IDs of the connection points to the grid. So they need to, basically map which operational boundary envelopes are associated with which national metering identifiers, and then therefore pass the correct portion of the result to the correct aggregators. The network participants need to verify the result of this mapping process, while the aggregators cannot know the mappings of other aggregators, but must trust and rely on the result of the business process. Also, in our green proof solutions, we have found several applications that benefit from DLE infrastructure. Regulators and auditors can run an embedded node on a DLE chain, for example, and trust the accuracy of the results as they have run the same business logic and received the same result. So they can really verify the result of the consensus mechanism, and in this example, validate the validity of the issued proof certificates. And we have another example here for the a decentralized marketplace for flexibility services. So the business logic here matches bids and offers for flexibility. Each network participant is heavily impacted by the business process result of other participants and need to verify the accuracy of the results. Parties such as service providers not running a node need to trust the accuracy of the matching result. So for example, yeah, aggregators need to really trust that trust and rely on the accuracy of this matching process for their flexibility. And the consensus from many distinct parties, the consensus in the result really gives them this trust and reliability. And there's many more use cases that we have found. These are just some that we have started working on already. I'm now going to pass you over to John, who's going to discuss the importance of decentralized identity resolution.
Right, thanks, Toby. So as Toby said, I'd like to discuss decentralized identity resolution and how the DLE is a good fit for this use case. This is another use case that we've identified. And for this discussion, I want to use the example of document authentication. And this slide is showing how it's done classically. So you can imagine that a new poem appears, and it's claimed to have been written by Edgar Allan Poe. That's the identifier on the poem. That's the name. And let's say it has a signature. So the question is then, how can we know that the signature is authentic, that it really was done by Edgar Allan Poe? And classically, you would go to someone who can provide, they've seen the signature, so they kind of act as an example of it. Or maybe the signature is, there's reliable examples elsewhere. So the example is retrieved, and then we can compare the signature to this known authentic signature. So that's how signatures are done in a classic paper-based way. And this then transitions to DIDs and digital signatures. So that's the next step. And now, rather coming back to the energy sphere, we could have a credential about an energy asset, and there's an issuer and a signature. So very similar to the classic paper-based example that we just saw. And similarly to the classic example, how can we know that the digital signature is authentic? And the answer is that we need a public key bound to the identifier. So we need to be able to say that the issuer, in this case, it's a DID example 123XYZ. What is its public key? Because to verify the signature, we take the document and the public key. So that's where the DID document comes in. It helps us answer this public key binding to identifier question. So you can see an example DID document, or at least a pseudo DID document in the bottom right there. You've got the identifier, date example 123XYZ, and it's bound to some public key. And that's living on a DID registry. So there's a few logos there above the example DID document. There's Sovereign, Kilt, Ion, and Energy Web. And these are all examples of DID registries, of sources of DID document data. So that leads us into why decentralized identity resolution is very valuable. Because of these multiple sources of DID information, being able to support all of these sources can be quite onerous. You can see this diagram on the slide shows a node that has connections to the DID registries that I was talking about. There's a Bitcoin RPC, an Energy Web RPC, a Sovereign RPC, a Kilt RPC, where RPC stands for Remote Procedure Call. It allows one to interact with these sources of data. So the idea of how a decentralized DID resolution could work, it's very similar to the previous slide where there's a request for a DID document. That's how it starts, at least it starts similarly, but then the processing is done by a set of nodes. And we think the DLE is a good fit because from a technical standpoint, because the DLE has very flexible support for its data sources. So the DLE allows us to reach out to these different sources, gather the data and return it to the requester in the form of a DID document. So technically there's a really good fit, we think, between the DLE and decentralized DID resolution. And from a business standpoint, the benefits are that there's a reduced operational burden for the DID requester. So if I'm wanting to onboard assets, say into my energy use case, and I want to be very flexible on where the credentials about the asset could come from. And so I want to support many different issuer DID methods or DID types. It can be quite onerous for me to then support all those connections. There's dozens of DID methods currently, and it's plausible that one could receive credentials from many different identifiers. So it's operationally intensive to maintain those connections. That's the first bullet point. And we anticipate that a chain which is public, which is shared, has the benefit of amortizing that operational cost between many requesters. And so that's another cost benefit, but the challenge is then how can we trust such a public service? And that's where the proof of good work consensus that Toby was mentioning. Right, so that's in a nutshell how decentralized DID resolution will be working. More details to come. I think on to the next section where Kamil will be talking about how enterprises can adopt these DLE-based solutions. Over to you, Kamil.
Thanks, Don. So the next topic that we would like to talk about is SSRE, which stands for Self-Sovereign Runtime Environment. And this is somehow our answer to the challenges that throughout the experience of working with the different projects we have identified. So just from the start, as you guys know, a large chunk of let's say the projects that the Energy Web is conducting, it's being done with the cooperation of the different stakeholders, and lots of them are large enterprise and kind of huge companies. And we do see that the stack as we have right now and the implementation of the projects cooperating with these companies comes with the, let's say, certain challenges. And those challenges, we believe that can be somehow addressed by this SSRE that we envision. Those challenges can be grouped in general by two different distinct, let's say, areas. One of them is related to the deployment or the way of deployment or the way of consumption of our services. And another large chunk is related to the packaging or what actually consists or is related with the deployments or the services that we are implementing with the cooperation with those different enterprises. And those challenges are problems, just to name a few, are strictly related to the, let's say, the nature of how those big enterprises look like. So very often those companies, for example, do not have that much resources as it is anticipated. So for example, they have either no or very small IT departments. And this is kind of natural because maybe their biggest, let's say, business value comes from the totally different sector. What is more, kind of it might happen that not only they lack resources in-house, but they are also lacking some kind of partners in terms of the different companies that could do those projects and implementations on their behalf. What is more, we do see that there are certain risks that they anticipate, those different companies might anticipate, related to the open source. That comes back again to the resourcing. So for example, not only you would need an IT resources to implement certain project, but also there is a big chunk that is coming later, especially if that service is supposed to be production ready, that is related to the maintenance. What also we somehow see that is kind of a challenge is that for now, there is no perception of our stack, so those building blocks that we develop, of being enterprise ready or maybe enterprise grade. Yes, so those building blocks are not anticipated yet that way. And what comes and is also related to somehow the way how for now we develop different artifacts is entry point and complexity. Obviously, for someone who is tech savvy or is coming from the IT, using tools like Kubernetes, Docker, etc., might be very, very simple, but it's not always the case. So this is the first group. And the second group related to the packaging itself can be represented by the challenge of, let's say, over-tailoring the solutions. So as you think, up to this point, usually how we conducted business was to, for example, once we found a business case, we somehow tailored different sets of systems or services for that particular use case. So the agnosticity that could be implemented that we think might be beneficial was not really the crucial case, or not like something that we put the biggest emphasis on. And this is something that, again, SSRE is willing to change. And as a bypass of those, let's say, solving those problems with SSRE, we do think that we might have additional benefit, which is increased scalability or increased adoption of our tooling. So all in all, just to emphasize again, our envision for the SSRE, or the goal is to play as a major factor in reduction of the overhead, decrease in entry-level complexity, making the impression that we are really enterprise grade and enterprise ready, decreasing the maintenance, and really having the thought of agnosticity on the back of our mind, always related to the tools that we are developing. And those charts that you see on the bottom of the slide are kind of also mimicking the transition that we are willing to take in the context of developing SSRE. So we would like to further increase self-sovereignty, however, not really further increase the adoption complexity. Can we move, Toby, to the next slide? Yeah, so establishing that, I would like to deep dive into those two distinct groups. So first one, I would like to deep dive to the self-sovereign part of the SSRE. So in our vision, on our anticipation is that, let's say the big thing or the big changes could come when we adopt a SaaS or PaaS-like experience. So with that, we are changing the way our solutions or our deliverables will be consumed or implemented. Instead of relying, let's say, on manual actions, we are thinking here about really self-sovereign way that you might let's say, know from those SaaS or PaaS-like platforms. With that move, we are also anticipating being closer to the customer's enterprise, to the customer's infrastructure and systems that are already there. For example, being present on their public clouds. This screenshot that you've seen here is obviously artificial, but could represent, let's say, something tangible and something that we aim for. So this is the screenshot from Azure Marketplace, and you see on the top left there is a certain service branded with Energy Web. It could be, for example, DLE. So the enterprise could consume it directly from the public cloud. And all of that, we think, will first of all additionally enhance the user experience and provide this sort of feeling that we are enterprise grade, that we are enterprise ready, and we are providing solutions like this. And the one more thing that I would like to emphasize here strongly is that we are not trying here to reinvent the wheel. Our sole focus here is on something that we think makes Energy Web unique and brings value, such as DLE, while other things that are already established, so for example, way of consuming a service via, for example, marketplace offering, we would like to leverage further rather than build it from the scratch. Can we move, Toby? Yeah, and the second thing that I would like to a little bit deep dive is this runtime environment factor of SSRE. And the best way probably would be to describe it based on examples. So how would you, let's say, how could it work? How could we make it agnostic, and how can we package actually our runtime environment on SSRE? So you can imagine that you can go to the, as I mentioned, to the public marketplace on your cloud, let's say whatever cloud you are working on, AWS, Azure, whatever. And there, for example, you can find a governance node branded by Energy Web. And this governance node, once you subscribe to it, can provide you a gateway to further deployments of different blockchain services. For example, a new DLE chain. And once you have this new DLE chain, thanks to this governance layer, you might want to, for example, nominate a new validator. And it will allow you to do that. Or maybe you would like to enroll additional participant that is willing to take part in your system. Again, this could be possible thanks to that governance layer that was in the first place deployed in a very easy way based on some kind, for example, of subscription. And other way around, you can imagine that we can go even maybe deeper. So for example, instead of being in the marketplace, maybe we will be directly on the public cloud. So there maybe you will be willing to find the blockchain, let's say, domain under the public cloud, where will be where different Energy Web branded services related to the different use cases could be directly consumed. So again, the user experience will be really seamless, and the overhead really minimalized. And I'm purposely repeating this thing again here. We are not willing to reinvent the wheel. We are really willing to just go for something that makes us unique and leverage the things that are already existing. And just to name a few examples, because we did already quite some research on top of that, there is, for example, Umbrel service that is represented by the screenshot on the top right, that is effectively a runtime environment on the Bitcoin network. So as you see, it mimics the further deployment of different apps up there. And other examples, slightly from the different angle, that could be addressing this runtime part and different blockchain needs that are common regardless of the system that you are developing, is Hyperledger Firefly. So basically, you can imagine it as a supernode that allows you to seamlessly integrate with multiple different layers. So, for example, monitoring that you are using, and it can support multiple, let's say, services on that. Directly integrate with a smart contract or allow for the deployment of a smart contract on the given chain. Integrate with your blockchain node, etc., etc. Yeah, and on that note, I will pause here and voice back to you, Toby.
Great, thank you, Camille. Yeah, so I think now, thank you very much, everyone, for your attention and your time. I think now we would like to open up to a Q&A session. And we can look at some of the questions posted in the chat, or if someone wants to raise their hand, we can also come to you and unmute you as well.
Okay, I see there's couple questions coming in. the Q&A. We've got one. Let me just give a read through them here. Okay, I'll start with the first one. So can you give a detailed step-by-step explanation of how the DLE works in a specific example? What is the input? What are the operations? What is the output? If I were to guess the direction we should take this question, I think we should go in the operating envelope example. Maybe I could pass that over to you, Toby. I think you're most familiar with it. And perhaps Camille and I can try to fill in some technical color if needed.
Okay. Yes. So the operating envelope partitioning in a more detailed example is you have a market operator. I think the example that we're working with now is in Australia. And the DSO basically receives a batch of raw data, which has synonymous IDs, and with each ID they have like an operating or like a value, a max and min value for which this particular national meter identifier can ramp up and ramp down consumption or generation to provide a flexibility service to the grid, right? So it's the actual operational boundary. And this is, the DSO has no idea who actually owns or which aggregators are responsible for actually controlling and managing the devices behind that particular national meter ID. So they just receive this like raw batch data, and all of the participants in the network, so be them the actual DSO, the TSO, AMO, which is the market operator, they don't want to have a very centralized process. They want to have a lot of transparency in the actual process of mapping these, mapping the ownership of these IDs, these operating windows, to the actual aggregators. So there's a separate data file which actually has the ownership mapping of aggregators, the aggregator IDs. And what the decentralized logic execution does is it partitions the data and assigns the operating envelope, and basically assigns the operating envelope to the correct aggregator. And then the aggregator is able to, the aggregator then receives this data, and they're able to understand the operating envelope, the operational limits that they're able to operate in.
Okay, thanks, Toby. I don't have much to add on that, but perhaps there's a, I think, related follow-up question, perhaps from the same person. What are the conditions to run a node for a certain task, and what does the reward punishment model look like in terms of proof of good work? I would think that's also a question where you're best suited to answer, Toby, I think.
Yes. So
yeah,
in this example of this network, you have a network of nodes who are running proof of good work. So they're running a logic engine, and they basically each execute the business process individually. They then commit and submit their result to the consensus palette. When the consensus palette has received enough results, it then calculates the correct result of the business process output based on the majority rule. And it rewards the nodes who got the correct answer in the correct or within the first few blocks, basically. So who submitted the correct answer in the first blocks, they get rewarded. And the nodes that were late or incorrect, they get punished. So basically, to submit your result, you need to commit a certain stake. And that stake is lost if you are late or incorrect with your submission.
And maybe just to add on top of that, that what is bound with this is like some kind of natural competition related to the efficiency. But this efficiency is related to the, let's say, result of the actual business process. So not only you are competing to get the reward just for the sake to, for example, as in Bitcoin, figure out some computational problematic mathematical challenge, but actually you are contributing to actual real business case. So the efficiency factor here is important also from the standpoint of the business logic and the business problem that they are dealing with.
Okay, thanks, Camille. There's a question from Paul about how this compares to other protocols that deal with these types of problems. And can you restate the key problem in the response? Maybe a way to do it is to go to the slide where we introduced the problem. And if we start with the key problem and then come back to other protocols. Do you want to take a crack at the key problem again, Toby?
Yeah, sorry, which question is this? Okay, how does this? Okay, so yes, so the key problems on certain markets are the localized energy markets. Yeah, maybe I'll just explain the problem definition then. So we synthesize this into, you need customized network configurations, localization of nodes and data flow boundaries. For example, like with AMO in Australia, they actually have, there's actually geographical confines on the location of the nodes. So they have to be operated within Australia and no data can flow outside. They really they want the chain to be governed by local participants. And they really want the chain to, some of the government structures and things like the block time, for example, the block time needs to be very low for certain business process operations. So they really want to have a high degree of customization on that and not rely on a block time set for a public blockchain network. There are often parts of the output that need to be publicly verifiable. So for example, I mean, this is getting a bit into a DLE chain communicating with with the parachain, but with this sort of ecosystem, you can have a DLE chain send transactions to a more public parachain, and then certain parts of the data from the output result can be on a public chain and be verified, or at least have, yeah, I mean, the hash of the result can be used for proving certain things to the public, say. And then also, certain block finality can be handled by certain submissions to this public chain as well. So yeah, that's the problems. Can you restate the key problems in response? Okay. So other protocols that try and deal with this. So we have the private decentralized ledger. Again, highly customizable, of course, but you don't have this ecosystem. You can't interoperate with other chains very easily. Not all participants. So yeah, the nodes in the chain aren't all executing the same business logic process, so they can't sort of verify the outcome of another node's business process output because, yeah, they're not running the same business logic, and therefore, if they get the same result, they know that this business logic was executed correctly. And we have the lack of cross-ledger consensus. For So I think I mentioned that with the example of the double spending. If you have two different chains and one single volume of flexibility offered on them both, you don't want to be incentivizing or double counting that flexibility volume. You want to have a shared state between the two chains and really ensure that this service was only offered in one of these markets. And I think, yeah, we touched on the smart contracts aren't really designed for such complex, sophisticated business process execution. They're more designed, yeah, they're just not really designed to, have a lot of sophisticated code in there and really execute complex business processes. And the public decentralized ledger, so obviously you got the public verifiability of transactions, but then you also lack the ability to have privacy as well. In the raw input data could be very sensitive. And maybe you only want certain parts of the output to be shared publicly, for example. So there's a lot of complexity there in trying to have these different layers of privacy and what is publicly verifiable. And again, you have the same sort of smart contract issue.
Maybe just to build on top of what Toby said and to emphasize this smart contract thing, this is because this is kind of a big one, yeah. So with the DLE, the actual execution of the business logic is off-chain, so it can be, let's say, as efficient and as powerful your machine is that is running this DLE, which in the smart contract could be much more problematic. So this is really, again, really, let's say, step into the efficiency, let's say, domain.
Yeah. What is the next question?
I think that's a good segue into the question from Felix, perhaps talking a bit more about the tech. Felix is asking, can DLEs be compared on the functional and also technological levels somewhat to TEEs? For example, also like integrity and substrate off-chain workers. And there's a second part, but maybe about the DLE chains being parachains. But maybe we'll tackle that next. Yeah, maybe we start with the substrate off-chain workers bit. So a DLE currently is using substrate off-chain functionality. I think it is very similar to the off-chain worker. There's an extension to that existing functionality to make it more flexible. I believe the existing off-chain workers currently rely on block production to be triggered. We're removing that limitation for flexibility. Not sure if Toby or Camo, you have anything to add to that substrate off-chain workers, but we're using substrate technology heavily in the development of DLE. Okay, maybe that then tackles the substrate comparison, and then relating to TEEs. I'm not maybe the best person to answer that necessarily, but my understanding is that there's some relationship in that a TEE can confirm what is being executed in a given environment, the trusted execution environment, but the proof of good work consensus is relying on a voting model. So it's possible that someone could execute different code, but we rely on, or the proof of good work consensus mechanism relies on a voting mechanism to ensure that a majority of participants of the DLE execute the code in a trusted way. Anything to add to that? Okay, maybe then the second part of Felix's question is about would we imagine DLE chains to be parachains on the relay chain, or are they wholly separate? From my perspective, that's a question we're still working on. I think the DLE chain, well, the parachain to relay chain connection has constraints related to that connection, but also benefits. So I think we're looking at simultaneously removing the constraints while also getting the same benefits of relay chain connection, for instance, cross-chain messaging. So we're looking at different ways of doing that. I think there's maybe some in between the relay chain or being wholly separate. It's maybe a bit of a sliding scale, and we can get the best ways, the best of both worlds. Anything to add there? Okay, maybe we'll move to Gaetan's question from the Block Daemon team. He's asking, can we re-explain which type of companies in the energy sector can benefit from DLE chains the most and why? I think the best way to answer this one is to look at the use cases that ties in the DLE with the energy sector. So we talked about OEP a bit, but we can talk about it again, or highlight the green proof and flexibility.
Yeah, I mean, I guess I wouldn't say which type of companies, it's more which solutions or which business applications. So that can benefit the most. So I think it's business applications where the result of the business logic needs to be trusted and verified by all the participants in the network, where the input data cannot be public, but each participant in the network needs to trust in and verify the result. So this could be, I don't know, like a consortia for supply chain delivery, where each of the participants in the network is heavily reliant on the results and the business process output of other parties. And they really need to be able to verify that without the actual input data being publicly released. So I think, yeah, I mean, we can share these slides after as well, but I think all of these use cases, they're all like types of business applications as opposed to actual, categories of companies which can benefit from it.
Okay, thanks, Toby. The next question is from Bart, who's thanking us for the presentation. Thank you, Bart. Thanks for attending. What will the cost model look like to use this service? And how do we ensure that the results are effectively true? Is the business logic compiled like a smart contract? Okay, only a couple minutes left, but we can get to these. What will the cost? Yeah, so I think the cost model question to me ties into the rewards model. There's the cost of operating the node, but it's related to the rewards side of things. How would you characterize this question, Toby?
Yeah, I'm wondering if it's like this sort of cost to the enterprises. And so, yeah, I think, yeah, when we're not really experts in the sort of cost model, but I think we are also looking at, similar to like software as a service solutions, where there's a more sort of fixed, maybe fiat service payments could be one. But yeah, I think that's probably for a different presentation, really. I don't think I'm the person to really go into that.
I think this is going to be addressed very, very soon by different webinar by Jesse and Michał. So those details will be covered up there.
Okay. Yeah, maybe just a quick answer to your second question, Bart, and then we'll wrap up. Yeah, the business logic is compiled into the DLE nodes, and the truth of the result, I would say, though, is more based on the proof of good work consensus. model, consensus mechanism. Maybe with that, I see we're at the top of the hour. Maybe I'll pass it back to you, Aurora, to close the webinar.
Yeah, sure. So thank you very much to our great speakers today. And thank you everyone for joining us. As always, we'll be posting the webinar on our YouTube channel. And yeah, if there's any further question that comes up later, you can always reach out to us and we'll try to answer all your questions. So yeah, thank you everyone, and hope you have a good rest of the day.
Thanks, everyone.
Thanks.
Thank you. Bye-bye.
Bye.